Okay, so hopefully it's recording. So this is what I have so far. There's a phrase. I asked the user for some input. Here, maybe just a word. We're going to simplify a little bit, and then just make it a word, so we don't have to deal with spaces. But you can add, more code to it if you want. So now we're looking at. We read in the line that, or the phrase that the user put in, and then right now we're just printing it out, just repeating it. And then here we create a new man, we draw it, and then we print out a blank line. And then what I did is I just created a loop that took the phrase and just printed out an underscore for every letter in the phrase. So it goes through the phrase length and reads the phrase one at a time. Well, it doesn't really read it one at a time. It just prints out an underscore based on the length. And then here, I just was testing the man class. So I just pretended to be making guesses to see if it would draw the whole man. So I'm going to run the program right now, and we'll see where we left it last time. So I enter a phrase. There's my phrase. And you see it draws the whole thing because I added all these guesses. But what I want to fix today is just to make a loop here based where you ask the user for a letter. And we're going to do this while a man keeps telling us, or the man is telling us that the game is not over. So we're going to do a type of loop called a while loop. So far, all we've done is for loops, where we're doing a certain number of times. But when you don't know exactly how many times, at least in this code, you're going to go around in the loop till you get that information from somewhere else, like the man class, then you're going to have to use a while loop instead. So you type in the word while, and then you want to say, well, while the man object, we'll ask him, is game over? See that one there? And we're trying to ask us if the game is not over, because we want to keep looping and asking these questions while the game is not over. Okay. So that's what you say, while the game is not over. That's how you say that in English. If you want to put a comment there, you can do that, just to say, do the loop while the game is not over. Okay. So if it's not clear what I'm trying to say there, maybe it's be helpful if I put in a comment. Okay, and now we're adding in the body of the loop. So what we do is we open that up with an open curly brace, and then there's a closed curly brace. First thing we want to do in the loop is we want to ask the user to enter a letter. Okay, so this is maybe the first time, or maybe it's the third time, who knows. We're going to assume the letter is wrong. Okay, so basically they get more than 7 guesses, right? I mean, we said 6 guesses, but it's really, they get 6 wrong guesses. They can have lots of guesses. Let's say a lot of them are right. They might even have 12 or 13 guesses in a round. So it's really not the number of guesses we're counting. It's the number of incorrect guesses, I suppose. So that's why we're relying on man to tell us whether the game is over or not. We're not counting guesses here. They enter a letter. We're just going to ignore it, I guess. I guess we have to eat it. So we've got to eat it off the command line. So we would say, maybe we would say, yeah, I think we could use our phrase again, although we don't want to mess up our phrase. Yeah, so before our loop here, we're going to create just a short little string. We're going to say, we'll just call it letter, and we'll make it a, yeah, the character class is probably what's the best one to use. And so we say char, and then we say, maybe we just call it letter. Okay. And then to read the char class, and this is what's frustrating about Java, is it's not very consistent. They have, so we say letter, And then we want to use the scanner to do that. So our scanner is called in. And you figure, or we called it input, I guess. And you'd figure that input would have a method called next letter. And so if we look here, we have next, we have next doubles, next floats. But notice that there's no next char for some reason, okay? Which is frustrating. So what we do is we say, well, we say input.next, and that gives us a string, and that'll give us the whole line if they give us something. See that first one is a string. So we do that first, and then we say char at, and this returns a char. Well, what position do we want to get the character at? We want to get that at position 0, which is the first character in the string. Hopefully there'll only be one letter in the string, but if they type in more letters, we're only going to accept the first one. So we're going to put in a 0 there. And that'll give us the first letter of whatever they type in, which is cool. Other thing we want to make sure of is we want to capitalize it. So we would say, well, hopefully char has a 2 uppercase. We'll see. So we say 2 uppercase. We're trying to convert it to an uppercase. And notice char does not have one. So where can we do this? I think a way to get around that is we know next returns a string, and I know strings has a 2 uppercase, so we'll say 2 uppercase on that. And then once the whole string is uppercase, then we'll get the first letter. So that's pretty complicated, certainly. Now that's pretty fancy coding, so you'd have to say something, say get the first letter of the string, capitalize it, and yeah, I guess capitalize it. That way we're just dealing with capital letters. Now, at this point, this is where we check to see if the letter is in the string, right? And we're going to add this later, but check if letter is in the phrase, I guess, or is a repeat. Say they've already made this guess. So you'd have to do some checking there. But say it's a wrong guess, we're going to assume that it's a wrong guess. So we're going to say, well, we need to print out we need to keep track of all the letters they've used and print them out each time we refresh the screen. So what do we do instead? Well, what do we do here? Well, we can tell a man to add a guess. This is a wrong guess, I guess is the way to say it. And that will tell the man when we draw a man next time, that it's going to add a piece to the puzzle there. And we'll just do that for now. Let's not worry about, and then let's not worry about keeping track of the wrong guesses quite yet. But here, this is where we draw the man at the bottom of every loop after each guess. Where should we draw it? Yeah, I think it's right there at the bottom of the loop is the best spot. Now remember, we need to close our input buffer where the compiler complains. But our code's looking a little bit better. Here's letter. It's telling us we're not using it for anything. We're storing something there, but we're not actually testing it. And it's noticing that. But that's more of a warning rather than an error. You see the line is green instead of red. If you have a red line, then it won't compile or run. But let's try it and see what happens. Let's see if we can get just the flow of the game running. So I enter a phrase like dog or something. So we need to print a blank line, but you notice that there's no parts to the man being drawn yet. So we put in the letter K. K is not there. Notice we didn't print it out, but note that it did print the first part of the Hangman. How about J? J. Nope. How about H? Nope. O. O would be in the word dog, right? So typically it wouldn't draw apart and it would be correct letter. But we're just assuming everything's wrong right now, just to see if we can get the thing to draw. And notice the game's over because we used up all the pieces of the man, and the man keeps track of that, right? So this is going to be our main driver then for our game. We've got a structure now where we can actually add in these checks to see if the letter's there. We can also add in maybe a way of showing what letter they've used so far, but that means we have to store that somewhere. I think the best way to store that is just append it onto the end of a string. So let's see if we can just do that quickly. Here we'll say, we'll make a string called wrong guesses, I guess. Right? And every time they have a wrong guess, let's just assume it's wrong like we've been doing so far. We can just say wrong guesses plus equals letter. So we're keeping track of the letter. Doesn't like that. Did I misspell it? Oh, it says it hasn't been initialized. Oh, I see. So we have to start out with an empty string just so that the compiler doesn't complain. Okay, so we start out with a string that doesn't have any characters in it. And then we add characters to the end as they make wrong guesses. And then what we might want to do is after we draw the man, we could print out the wrong guesses. So we'd say and you can just say wrong guesses. And that will print the wrong guesses out on the line. It might be good to also put like a label on it, like incorrect guesses. And so we can see these are the letters that aren't part of the word. Let's just run it and see what we get when I type in random stuff. So I'll put in the word cat, let's say, enter a letter D. See, it's showing us our incorrect guesses. H, there's no H. S, $, C. And it's keeping track of which letters we've guessed so far that are incorrect. Okay? So I think it's a good place to stop for today, given we're out of time almost. And then next time what we'll do is we'll add this stuff to check to see if the letter's in the phrase. And then the other thing we have to show that we're not showing is as they fill in letters in the phrase, we insert that letter and display the phrase with either blanks or if they've guessed that letter, put that letter in the phrase. That's going to be kind of hard. Our challenging things are going to be, what if the letter appears more than once in the word? We can't just show the first one. We have to show all of them. So that's going to be a little bit of a challenge. The other special cases are, what if they type in the same guess twice? We have to be able to detect that and tell them, oh, you already guessed that one. Try again. So we have to put something like that in. And then we also have to figure out if they've got all the things filled in. Say they guessed all the letters. Now they know the answer. We got to detect that and be able to tell them they won. Here, we're not even telling them they're lost yet, but we have to check that as well. So winning and losing conditions, and then some difficult coding after that. But so far that's what we have. Now, I do want to point out, let me just, I did make some assignments for us so that you can take a look at them. Here's our assignments. And you can see there's the Madlib one. Here's the user guesser game, the first one. Here's the second one. Those you can just turn in the main method because I think we only have, or the main Java class file. But this one is going to take more than one file. So I'm thinking on this one, what you should do is just share your REPL with me, and then I'll know that it's yours, and then I can grade it that way because it's more than one file. But that's all I have for now. Any questions on what I've just gone over?
Well, I have a other question. Is there
Yeah,
any other projects I could work on?
yeah, it's a good question. I think you're pretty advanced coders, so you know, since we did do Hangman, and Hangman's similar to Wheel of Fortune, you could think about making a wheel and people spin it and kind of trying to model the Wheel of Fortune game. It's similar to Hangman, right? You get a phrase, they see parts of it, but you win money instead or prizes or something. That'd be one way to extend the Hangman game. There's another game that you could look up online. It's really interesting. It's not, they call it the game of life, but it's not really a game. It's more like a simulation of biology, actually.
Yeah,
Uh,
I've heard of
and
it.
yeah, it's really kind of cool. And so if you want to try that, you can do our screen clearing thing with a delay on it. And then you can do it with a text-based engine like this. And it makes it look like little things are growing in a petri dish. And it's really quite interesting. Another thing you could try to do is model the spread of coronavirus in the computer, making a simulation of that, but base it on what you see in the life game. And you can change the R value of how contagious it is, and you can see what the effects that it has on the simulation. So yeah, there's a lot of cool things you can do with that. But that's if you're done with the Hangman game. Most of us aren't, though. We're just getting started on the Hangman game. But again, I'll post this video out online, and then you'll be able to access the video, and you can get this coded up for yourself. Any other questions? Okay, I'm looking for mics being unmuted. There's none. All right, well, thanks everyone for coming. I appreciate it. If you have any questions or you get stuck, please feel free to email me anytime except for Friday because we can't work on Friday for some reason, the lawyers say. So, but any other day, just shoot me an email. I'll get back to you, okay? All right, thanks everyone. Everybody have a good day. Thanks for
Hey,
listening.
Mr. V.
Yeah.